And so our answer here, if we get a value of 0.071, that means that the probability that 7 candies in the bag are strawberry is about 7.1%. You need to take this decimal and move it 2 spaces to the right, and that gives your answer as a percentage. We're going to head over to check your progress. Example 3. This one is about golf balls. Out of all the golf balls produced by a manufacturer, 13% are flawed. What is the probability that 2 balls out of a package of 20 are flawed? Go ahead and pause the video. Use the formula that we looked at. When you have your answer, go on to the next slide. Our answer this time is D, 26.2%. You should have done 20 combination 2 times 0.13 to the second power times 0.87 to the 18th power. And that will give you 26.2%. Next, we have a key concept on the mean of a binomial distribution. The mean, or the average of a binomial distribution, is given by the formula mu. This is the Greek letter M. Mu equals the number of trials times p, the probability of success, n times p. We're going to use that formula for example 4, which says a family has 4 children. Assume that when a child is born, there's a 50% chance that the child is female. Determine the probabilities associated with the number of daughters in the family by calculating the probability distribution. So it's the possible outcomes here will be that they have no female daughters, no female children. Daughters obviously is redundant. They have 1 female child, they have 2 female children, or they have 3 female children. So first, in the binomial experiment, n is 4, there's 4 children. The probability of success is 0.5, that they have a female. Probability of failure is also 0.5, they have a boy, a male. And so we're going to look at expanding the binomial p plus q to the n power. So the way this expands, I can talk about this. This is something using Pascal's triangle. Is 1 p to the 4th. Notice how the powers for p are going to decrease as we go through the terms, and they're going to increase for q. So we have p to the 4th, q to the 0. Then we have p to the 3rd, q to the 1st, p to the 2nd, q to the 2nd, p to the 1st, q to the 3rd, and then just q to the 4th with p to the 0. That's how you expand a binomial. The coefficients are 1, 4, 6, 4, 1. And we wanted to find out, so each of these things, if you type each of these into your calculator, you get the probabilities for each of the potential outcomes. So if they have 4 girls, that's 6.25%, which is the same as if they have no girls. If they have 3 girls or 1 girl, it's the same as 25%. And if they have 2 girls, which is the most likely event, that they have that happens 37.5% of the time. All of these numbers would add up to 1. All right, part B. What's the probability that the family has at least 3 daughters? So at least 3 daughters means that they have 3 daughters or 4 daughters. So we want to add up the probabilities of having 3 daughters and 4 daughters. That would be 25% plus 6.25%, which is 31.15%. And that's your answer. There is a more complicated way of doing this that involves using the calculator, and you will learn that if you take AP Statistics. Part C. How many daughters should the family expect to have? So finding the expected value. Remember, the expected value formula for a binomial distribution is the number of successes times the probability. That would be n being 4, the probability of a girl being 0.5. Therefore, they should expect to have 2 girls. The number of girls with the highest probability is 2 girls, so the answer is 2. And you figure out that it's 2 is by the thing that is the highest priority event. Or you just use the formula, which is n times p, n being 4, p times being 0.5. Half of 4 is 2. So the answer is 2. They should expect to have 2 girls. Let's look at a check your progress problem for example 4. This one is about coins. Go ahead and pause the video, read through the example, and when you have your answer, go on to the next slide. Okay, our answer this time is choice D, 76.6% of the time, or that's the probability that the coin lands on tails in 8 out of 10 flips, if the coin has an 83% chance of landing on tails. All right, that brings us to the end of Unit 5, Lesson 4 on the binomial distribution.